You know, May 30th is a golden day in math history. Actually, scratch that. It is without a doubt one of the greatest dates in the entire history of mathematics.
And here is why. On this exact date, May 30th, across completely different centuries and countries, some truly brilliant minds were either born or left behind an incredible legacy. And the crazy thing? Their work directly changed the modern world we live in today. So in this explainer, we're not just going to do a dry history lesson. I want to show you the hidden architecture of your daily life. Let's dive in and meet them, one by one.
Let's start with a bit of a mystery. Think about how a video game knows exactly where your character is on the screen. Whether you're exploring a massive 3D open world or just watching an animated movie, how on earth does the system track that movement so perfectly? Well, the answer takes us all the way back to May 30th, 1800, and a guy named Karl Feuerbach. Born on this exact date over 2 centuries ago, he was an absolute pioneer of geometry.
His massive game-changing achievement was co-inventing something called homogeneous coordinates. Basically, this breakthrough allowed us to perfectly map out 3D space using numbers. It's literally the mathematical foundation that modern computer graphics rely on today. Think about it. Without his coordinate system, our screens wouldn't have a clue how to render the depth and movement of those digital spaces we love to explore.
Which brings us to our first big takeaway. Every digital world we explore is built on invisible geometry. It is absolutely wild to think that a mathematician from the 1800s gave us the keys to our modern virtual realities.
Moving on to May 30th, 1814. Different century, new brilliant mind.
Now think about your phone for a second. How does your GPS calculate millions of possible routes in just a fraction of a second? When you hit a wall of traffic and it instantly reroutes you, how is it sorting through that mountain of massive data so fast?
The answer leads us right to May 30th, 1814, and a Belgian mathematician named Eugene Charles Catalan. He was born on this very day, and the guy just loved to solve incredibly complex geometric puzzles.
Catalan's historic work focused on figuring out all the different ways to break complex polygons down into simple triangles, just by drawing lines that don't cross. Now, I know that sounds like some dusty ancient puzzle, right? But the mathematical sequences he discovered, which we now call Catalan numbers, are exactly what modern computers use to sort massive data combinations and process algorithms super efficiently. He basically figured out the math of data routing way before computers even existed.
So it turns out the fastest way from A to B is actually hidden inside ancient polygon puzzles. Every single time your GPS finds a sneaky shortcut, you can thank Eugene Catalan and his 19th century geometry.
And now, jumping forward into the age of flight, a new era of danger and discovery. Let me ask you about something we all kind of take for granted. How do engineers know an airplane's wings won't just break off in high-speed wind? Flying at incredible speeds, thousands of feet in the air, is inherently super dangerous. So how do we make it so remarkably safe?
The answer is tied to an incredible mind who did groundbreaking work during World War I, Beatrice Cave-Browne-Cave. She was a total pioneer in the mathematics of flight, working at a time when aviation was wild, unpredictable, and really dangerous.
Beatrice worked on top-secret mathematical problems for the British Air Ministry. She calculated the exact loads and pressures on airplane wings and tailplanes during high-speed flight, essentially bringing mathematical safety to totally chaotic wind speeds. Because of her calculations, engineers finally knew exactly how to build planes that could withstand the immense forces of flight. She replaced deadly guesswork with absolute mathematical certainty, saving countless lives.
It brings us to this mind-blowing realization. Every safe flight you take is held up by invisible math. So the next time you're looking out of an airplane window at 30,000 feet, remember Beatrice Cave-Browne-Cave.
Finally, let's jump to May 30th, 1933, the dawn of early machines. Here's a real brain teaser for you. How did engineers build complex computers and do massive calculations way before modern microchips or even widespread electronic components were invented? Well, the answer leads us to a man named Semyon Aronovich Gershgorin. Tragically, his life ended on this very date, May 30th, in 1933. But the legacy he left behind literally built the future of computing. You see, Gershgorin didn't have silicon chips, no way. Instead, he built analog computing devices using physical, moving gears and mechanical linkages to solve impossible math.
He found ingenious ways to do complex arithmetic operations, like extracting square and cube roots using purely mechanical movements. He also created brilliant geometric visual bounds, like the famous Gershgorin circle theorem, to easily estimate complex equations in linear algebra. It's like a giant puzzle. He was doing computer science with physical metal and pure logic.
Before computers had wires, they had moving gears and brilliant math. It paints such a vivid picture of human ingenuity, doesn't it? We didn't wait around for electronics to compute. We used the mathematics we had to build the machines we desperately needed.
The pattern inside chaos. So, what connected them all?
We've traveled through time in this explainer, from 1800 all the way to 1933. Think about it. Karl Feuerbach mapping 3D space in 1800. Eugene Catalan solving complex data routing puzzles in 1814. Beatrice Cave-Browne-Cave taming aerodynamics in 1916. And Semyon Gershgorin building mechanical brains in 1933. Despite living in completely different centuries and countries, every single person we met today was searching for the exact same thing. They were looking for the pattern hiding inside the chaos.
Because they asked the big questions. Our world today has GPS, the internet, and safe flights. The tech you hold in your hand right now? It isn't just made of plastic and glass. It is made of centuries of brilliant human thought. Math really is the ultimate foundation of our modern world. So as you move through your digital and physical world today, what hidden patterns of chaos are just waiting for you to discover them?